Okay, we did not quite get finished with this example in the last video. One thing that I just want to mention to you, we just got done running this chi-square test for homogeneity on the calculator. The calculator reported to us these three things that I am highlighting here in yellow. It reported to us the chi-squared value, which is our test statistic. It reported to us the p-value, and it also reported to us the degrees of freedom. But I just want to draw your attention to the fact that up here, the degrees of freedom is always the number of columns minus 1 multiplied times the number of rows minus 1. So if you look at what we had here, we had 3 columns, we had 2 rows. So if I were to just do that by hand, the degrees of freedom, 3 columns minus 1 times 2 rows minus 1, I would end up at 2 degrees of freedom. Okay, it's not a difficult calculation to make, but the calculator does report it for you. Okay, so then we're down to the m in the phantom step here. Okay, and we would want to go ahead then and say that since the p-value of 0.0148 is less than the alpha level of 0.05, we reject the null hypothesis. Okay, that means we can say that we have convincing evidence that there is a difference in the age distribution for the game populations. Okay. I probably should have included up here in the H step when I listed the hypotheses what the alpha level was for this. I think it said it in the problem, but it's always good to include that and list that. Okay. All right, so it says here the expected counts and the chi-square test statistic, and the problem of how to do a lot of comparisons at once when you have this overall measure of confidence. When you're doing these multiple comparisons, it says an overall test to see if there is good evidence of any difference among the parameters that we want to compare, and then doing what's called a detailed follow-up analysis. I think we did a little bit of this with the goodness of fit test, but I want to show you how you would do it with this test, because it is a little bit different with the test for homogeneity. Okay, so it's asking us here to perform a follow-up analysis, and the goal when you do this is to try to figure out which observed count contributed the most to the chi-squared test statistic, and did it contribute more positively or more negatively. Okay, so here's how we're going to do this. Okay, what we're going to do is I'm going to go ahead and I'm going to calculate what each of the values would be if we were to take observed minus expected squared divided by expected. Okay, so I'm kind of working that by hand. You know, when we did the test, we just showed the first couple of calculations, and then we put ... because we ran the test itself on the calculator. Now, here's the bad news. When you do the goodness of fit test, it stores all those contributing values into a list called, I think, contrib or something like that. But when you do the just generic chi-squared test, which is what we use for the test for homogeneity, it does not store those in. So you'll notice I just kind of filled those in, and I'm going to go ahead and highlight here. These are each of the values that got added together. Oh, I didn't write this one here. That contributed to, I think, our chi-square test statistic. If I scroll back here, that was this 8.43. That came from, rather, all of these values being added up. Now, how you could do this a little bit on the calculator is you could enter all the observed counts into L1. You could enter all the expected counts into L2. And then you could, with the cursor on the top of L3, define that to be L1 minus L2 in parentheses squared, and then divide by L2. And that is basically what the formula is for how we got each of these values that I have highlighted here. Okay, and you hit enter and it'll fill these in, and it'll fill it in with like each of those values that you see up above. Okay, like that. Okay. So it's looking like, and I'll just draw your attention to this. It says note that this contrib that can only be used for the chi-square goodness of fit test. Okay, so as we look at this, it looks like the age group less than 25, actually for both populations, because it was contributing the same amount, contributed the most to the chi-square statistic. Okay, I'm getting that because that was the biggest value here. Okay, I'm going to say that dot A2 was 10 less than expected, and League of Legends was 10 more than expected. Now, if you're not sure where I'm getting that from, let's take a look back here. I went ahead and copied, here's the observed, here's the expected. Okay, we already said that it was that age group here, so that's these numbers right here, okay? So here's what I observed for dot A, but then here's what actually happened. So for dot A, the observed was 10 less than what I would have expected. And then for League of Legends, the observed was 50, but I was expecting 40. So for the League of Legends, that was actually 10 more than what I expected. Okay? All right, so that's how you do a follow-up analysis for a chi-squared test for homogeneity. Okay, we are just going to go ahead and wrap up with this last example here, just so we've kind of ran through one more. I do have a template here that'll make this go a little bit faster for us. Okay, so it says market researchers suspect that background music might affect the mood and buying behavior of customers. That's interesting. This was done in a supermarket. It says one study in a supermarket compared 3 randomly assigned treatments. Ooh, that is important to note here. 3 randomly assigned treatments. So in one grocery store, they played no music. In another grocery store, it looks like they were playing French accordion music. And then in another one, Italian string music, okay? Under each condition, the researchers recorded the number of bottles of French, Italian, and other wine that was purchased, okay? So they're not going to tell you in these problems whether you should be doing a goodness of fit test or a chi-square test for homogeneity. You need to know what to look for. And the one dead giveaway in this problem is we can tell with the language they're using when they say they randomly assign treatments is that this is an experiment, and we should most definitely be using the chi-square test for homogeneity, okay? So we have our conditions, but I know that I don't need to do the 10% condition or say that any samples were independent if it's an experiment. So I can cross those two off right away, okay? The treatments in this particular example are none, French, and Italian, okay? And that is the type of music, by the way, okay? And then the type of wine that was purchased, that's like the response variable in the experiment, okay? That's what like they're measuring, like what kind of wine did they buy when there was French music playing? Did they buy French music more likely? Okay, so the question is, are the distributions of wine purchases under the 3 music treatments similar or are they different? Okay, we don't do anything with this P step in the phantoms, okay? However, our null hypothesis will be, look, there is no difference at all between the distribution of wine purchased for each music type. In other words, kind of indicating, look, the kind of music you play, that in no way really impacts or influences what type of wine someone would purchase. The alternative is saying, well, there is a difference between the distribution of wine purchased for each music type. Okay. I included over here in the box just some reminders about how to get the degrees of freedom, the formula for how to calculate chi-squared, and, this is important, how when you're given two-way tables, which is what we have for tests for homogeneity, how to get the expected counts for each cell. Okay, so let's go ahead, when we do our assumptions or our conditions, I'm going to cross these off. I already have listed here that the samples were taken randomly. We were told that. Okay, we do need to get the expected count. We need to show that they all are at least 5. Okay, but you have to show what they are. All right. So as we do this, and you can look up above, I have to scroll down below here a little bit, but to fill in each of these, and it is very important, please remember that for expected counts, you should never round. Okay, never round this. So if it's a decimal, we're going to, carry that out to at least a few places. Don't round it up to the nearest whole number. Okay, the formula is row total times column total divided by grand total. So just to show you here for this top left corner in expected counts, for French wine, no music playing at all, there were 30 people in that supermarket who purchased French wine with no music playing. Okay, how many would we expect? Well, let's take the row total of 99 multiplied times the column total of 84, and we're going to divide that product by the grand total of 243. Okay, if I do that, I end up getting that I actually would have expected somewhere roughly around 34.22 bottles of wine, French wine, to have been purchased. Okay, we're going to repeat that same process here. It is row total times column total divided by grand total. So for French music playing and French wine purchased, I'm doing 99 times 75 and dividing that by 243. Okay, and that gives me 30.56. Okay, I'm going to go ahead and go through and fill these in, but you get the idea that it is row total times the column total divided by the grand total. That work does not have to be shown on your paper on the AP test, but these expected counts most definitely need to be shown. Okay, you can see the smallest expected count was 9.57 bottles of wine, so all the expected counts are greater than or equal to 5. That meets the large counts condition. I just had included here pictures of these distributions. This wasn't anything that the problem would have asked you to do here. Okay. All right, we're going to fill in the name of the test, chi-square test for homogeneity. I'm going to go ahead and fill in the first couple of calculations. Okay, remember this is observed minus expected squared divided by expected. Okay, I'm going to do the next one. Observed minus expected squared divided by expected, and then dot, 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 and then we'll give some room there, okay? I'm going to go ahead and jot down the degrees of freedom because I should be able to calculate that myself. It's the number of columns minus 1 times the number of rows minus 1. That's going to give me 2 degrees of freedom. Okay, what I would do next, and I encourage you guys to use your calculator for this, okay? What I would do next is I would just run the chi-squared test on the computer or on the calculator. Okay, remember matrix A is the observed counts. Matrix B, that should be the expected counts. Okay, you need to fill those up first before you even go to the stat button, the test button, and choose the chi-squared test statistic. Okay, once those are filled in, you're going to go through and do that. It is going, oh, I messed this up, degrees of freedom, didn't I? It was 3 columns and 3 rows, my bad. That would totally change the degrees of freedom. That would be 2 times 2. Degrees of freedom should be 4. Okay, I apologize. All right, so on the calculator, it should spit out to you that the chi-squared test statistic is 18.28. That gives you a p-value of 0.001. We then would say that a p-value of 0.001 is definitely smaller than an alpha level of 0.05. So we are going to reject the null hypothesis, which means that we actually have convincing evidence that, remember, this is always about the alternative. Convincing evidence that, and go back up, just look at the alternative hypothesis and write it down word for word, that there is a difference between the distribution of wine purchased for each music type. Okay, that would be our conclusion, that there actually is a difference between that. Okay, all right, that brings this video